Hello friends, today we are discussing about the delete operation of the linked list, how we can delete the node from the linked list. So we can perform delete operation from the linked list in three ways. Method number one, delete from beginning. Method number two, delete from mid. Method number three, delete from end. So how we can perform these operation we are discussing one by one. So say we want to delete the node from the beginning. This linked list is given. In this linked list, total we have the four node, node 1, node 2, node 3 and node 4. If we want to delete the first node, so after deletion of the first node, this will be here our linked list. So we have here, this is here our now first node. So after deletion of the any node, first node, in this way, we have to set second node as the first node. So our method is very simple. Remove first node. After it, second node becomes the first node. So if we talk about the code, then we can perform these operations like this. So p equals to head means p contains address of the first node, as head always keeps the address of the first node, and free p, first node is being deleted. After it, we are doing head equals to head arrow next, as head keeps the address of the first node. The next part of the first node, address of the second node. So we are setting head equals to address of the second node. So in this way, second node becomes the first node. So therefore, this is our detailed procedure of deletion from beginning. If we talk about the formal code of the delete operation, then we have here linked list. In this linked list, we have the item. Item is the integer part here. We have here next pointer, and we have here three pointers. Pointers are head, p and q. We have here delete at beginning function, and here we are setting p equals to head. P contains address of the first node. Now we are doing here deletion. The first node is being deleted here. Now we are setting head equals to head arrow next. This head becomes the our second node. Second node becomes the first node using this our delete at beginning procedure. Now we are discussing about the delete from mid. Say we have here total three nodes in the linked list, and we want to delete this particular node. Then how we can perform this task? So first of all, we have to keep the address of the node that would be deleted. Say we want to delete this node, and we have to keep the address of this node. And next point is here, we have to keep the address of just previous node. So here, this is here our just previous node. This node we want to delete it, and just previous node is this one. So we have to also retain the address of just previous node also. Now link previous node to the next node. So this is here our previous node, and this is here our next node. The previous node is linked to the next node. After this linking, we can delete this node to remove the node. So we can perform these operation like this. If we talk about code, then say p contains address of the just previous node. So p arrow next means say p contains address of just previous node. So in this case, p is pointing to the first node. So p arrow next means address of the second node. Now q contains address of the second node. So q is pointing to this node, and we want to delete here this node. And before deletion, we need here linking. We are performing here p arrow next equals to q arrow next, as q is pointing to the here second node. Next part of the second node contains address of the third node, and we are doing here p arrow next equals to q arrow next. So q arrow next means address of the third node, and p arrow next means here this location. So first node is pointing to the third node using this line. After linking, we can do here delete operation. So in this way, we can delete the node from mid. If we talk about the formal code, then p equals to head. P contains address of the first node here, and say we have here loop I equals to 1, I less than n minus 1. I plus plus. Say we want to delete here second node, the value of n equals to 2, the 2 minus 1 equals to 1, so 1 less than 1, our condition is false, so this loop is not execute if we want to delete the second node. So initially P is pointing to the first node, so therefore if this loop is not executed, so P contains address of the first node. And now Q equals to P arrow next. Now Q contains address of the second node as P contains address of the first node. The next part of the first node means address of the second node. The address of second node is being copied into the pointer Q. After it, we need here linking as Q contains address of the second node. The next part of the second node means address of the third node. So P arrow next means P contains address of the first node. So next part of the first node is pointing to the third node. So in this way, we can do the linking operation. After it, we can perform the delete operation using the free function. So this is here our detailed procedure of delete operation. Now, if we talk about the delete format, say this linked list is given. In this linked list, we have total 4 nodes and we want to delete here this node. After deletion of this node, this is here our linked list. So how we can perform delete operation? We are discussing various steps. Steps are, first of all, we have to keep the address of the last node. This is here our last node and we have to keep the address of the last node. Say in the pointer P, we are returning the address of the last node. We have to also keep the address of the second last node. This is here our second last node and we are keeping the address of second last node in the pointer Q. And now we have the remove the last node. The last node is being removed here. After it, next part of the second last node should be null. So in this way, we can set next part of the second last node is null. So if we talk about the code, then P is pointing to the last node. So free P, last node is being deleted here. And next part of the second last node, Q arrow next equals to null. So in this way, we can set the null. So this is the procedure from delete from end. If we talk about the code for delete from end, initially here, P equals to head. P is pointing to the first node as head always points to the first node, and we have here a we have here a loop P arrow next not equals to null. So this loop execute again and again until we have P arrow next equals to null. So P arrow next equals to null, as we know that next part of the last node is always null. So therefore P contains address of the last node after successful execution of this loop. So we can get the address of the last node in the pointer P. If we talk about the address of the second last node, then we have to refer the body of this loop. In this body of the for loop, we have the condition Q equals to P. Initially, P contains address of the first node. So therefore, Q contains address of the first node, and we are doing here P equals to P arrow next. As P contains address of the first node, so P arrow next means address of the second node. So we are observing here Q contains address of the first node and P contains address of the second node. So it simple means, say P suppose contains address of the last node, so Q contains address of the second last node. So we can get the address of the second last node and address of the last node using this while loop. After getting these addresses, we are doing here free function, free P. So as P is pointing to the last node is being deleted here, and we are doing here Q arrow next equals to null. The next part of the last node is being set equals to null. So in this way, we can perform the delete operation. Thanking you.